One port is used for data bus. In this case, all the displays terminals A to H are connected to that pins of the single port, as they are time multiplexed. Another port is used to turn on the various displays through a transistor, and this resistor is used to vary the contrast of LED. Here 4 displays, then 4 pins are required. If more than 4 displays are used, they are using the advantage of persistence of vision. They are time multiplexed. They appears continuous, but they are not continuous. First of all, this is on, then the next and next. Interfacing of ADC with 8051, that is analog to digital converter. Both parallel and serial ADC chips are available. Analog to digital converters are among the most widely used devices for data acquisition. A physical quantity is converted to electrical signal using a device called a transducer. In parallel, analog to digital converter, we have 8 or more pins dedicated to bringing out the binary data. The higher resolution analog to digital converter provides a smaller step size, where step size is the smallest change that can be detected by any ADC. This is the ADC chip, and in this in these connections we can check or test this ADC 0804. It is an 8-bit parallel ADC. It works with 5 volts and it has 8-bit resolution. V in and V in positive and V in negative. These are differential analog inputs. Now we have offset V in pin. V in negative pin is connected to ground and the V in positive is used as the analog input to be converted to digital. VCC positive, it is connected to positive 5 volt power supply. It is also used as a reference voltage when V reference over 2 pin is not connected, it is open. Next, V reference over 2 pin number 9 is an input voltage used for the reference voltage. This is input pin. Now we have clock in and clock R. Clock in is an input pin connected to an external clock source when an external clock is used for timing. To use the internal clock to generate to use the internal clock generator of ADC 0804, clock in and clock R are connected to a capacitor and a resistor as shown in the figure. Now we have chip select. This is active low. Read, it is also active low. Read is used to get the converted data out of the ADC 0804 chip. Then we have a write. A better name might be start of conversion. Write is for start of conversion and interrupt is for end of conversion. Interrupt is a better name, might be end of conversion. This is a output pin and is active low. It is normally high and when the conversion is finished it goes low. It is normally high, when conversion is complete it goes low. This is read and write timing diagram for ADC 0804. This is chip select signal, then write is active low, D0 to D7 data bus, interrupt, read. Chip select is set to low for both read and write. For read pulse and for write, first of all we have to start the conversion. For write, chip select is made low. After that, for the end of conversion, interrupt pin goes low. When end of conversion is there, then read is made high to low and chip select is made again low, then data is out. Clock source for ADC 0804. The speed at which an analog input is converted to the digital output depends on the speed of clock input. Two ways of providing clock to the ADC 0804: self clocking and from crystal of 8051. This is the 8051 connection to ADC 0804 with self clocking. In case of self clocking, clock R and clock in are connected to a resistor and a capacitor as shown in the figure. Here we require two ports. Port 1 is connected to data bus where digital data goes to 8051. By sensing this analog signal, this is converted to analog to digital, then it is gone to 8051, and port 2.5 pin is connected to read, 2.6 is connected to write and 2.7 is to interrupt. To start this pin is made low to start the conversion. When conversion is completed, conversion finishes, then this interrupt pin goes low and data is gone to 8051 by making read signal low. After that, we have interfacing connection of 8051 to ADC 0804 with clock from crystal of 8051. Here we get clock from this. In this case, clock R pin is left open and clock in is connected to the crystal of 8051 by connecting D flip flops. Use of 4 to 5 D flip flops is to obtain the correct frequency for the ADC chip. A single D flip flop divides the frequency by 2 if we connect its Q bar to D input of other. Q bar to D, it will divide the frequency by 2. So, we require 4 or 5 D flip flops to require the correct frequency. Next, interfacing of digital to analog converter 0808 with 8051. There are two methods of creating a DAC, binary weighted and R to R ladder. The integrated circuit DAC 0808 use the R to R method. The number of data bit input decide the resolution of DAC. The number of analog output level is equal to 2 raised to power n, where n is the number of data bit inputs. An 8 input DAC 0808 provides 256 discrete voltage levels of output. The digital inputs are converted to current and by connecting a resistor to current pin, we convert the result to voltage. Here is the interfacing diagram of DAC with 8051. Here we require single port, here digital to analog converter. Digital output from the 8051 is given to DAC, that is converted to analog signal. Figure shows the generation of reference current by using the standard 5 volt power supply. An I reference current output is isolated by connecting it to an op-amp. 741 with RF equals to 1 kilo, RF equals to, that is feedback resistor equals to 5 kilo ohm, we can monitor the output on the scope. Interfacing of sensor with 8051. Here we have temperature sensor. Transducers convert physical data such as temperature, light intensity, flow and speed to electrical signals. Temperature is converted to electrical signal using a transducer called thermistor. LM34 and LM35 temperature sensors are used. The LM34 series are internally calibrated and is linearly proportional to Fahrenheit scale, and LM35 series are internally calibrated and is linearly proportional to Celsius temperature. This is the flow chart of interfacing sensor to microcontroller. We can connect any sensor. Sensor information is analog world, that is temperature, pressure, light intensity, etc. Now we require a transducer which will convert one form of energy into another form. Now we require signal conditioning. Signal conditioning, the most common transducers produce an output in the form of voltage, current, capacitance, charge and resistance, etc. However, we need to convert these signals to voltage in order to send it to the A to D converter. So, we require signal conditioning. This conversion is called signal conditioning. Now, we will connect ADC, then microcontroller. 8051 interface to ADC 0848 and temperature sensor. Here we have used LM35 or LM34 temperature sensor, and ADC analog to this temperature sensor will sense and produce an analog signal after signal conditioning, and this analog signal is given to channel 2 of the A to D converter. Then this is given to, this is connected to 8051 by 2 ports. Port 1 is connected with data bus of the ADC, and port 2 pin number 2.5 is connected to read 2.6. To start the conversion, we will make this pin low, and after that when the conversion is complete, that is interrupt signal goes from high to low, and our program monitors that pin number 2.7, that is interrupt pin, and then a read signal, that is made active low, and data is, that is digital information is given to 8051. In this way we can get output. V out of ADC 0848 corresponds directly to temperature as monitored by LM35 or LM34 sensor. Here the diodes, we use LM336 2.5 Zener diode to fix the voltage across 10K pot at 2.56 volt, and this overcome any fluctuations in the power supply. Thanks.